Okay, this is Milne's predictor corrector method. So as its name tells, here we use two formulae. One is to predict the solution, and is to correct the solution. Suppose that there is a differential equation. A differential equation that initial value problem is given. Let it be dou by dx is equal to f of x comma y. But in this Milne's predictor corrector method, to find the solution of y for any value of x, it must be known. That means the solution must be known at four consecutive values of x. If the values of y are known at consecutive values of x, then only can find the solution at the next step. In earlier methods, I have seen the solution at x is equal to x naught only. By knowing the solution at x equal to x naught, we are used to find the solution at x is equal to x1, which is given by x naught plus h. But in this method, the solution must be known at four consecutive values of x, like this. Suppose that for this differential equation, one differential equation given, dou by dx is equal to f of x comma y, with the initial conditions, y of x naught is equal to y naught, and y of x1 is equal to y1, y of x2 is equal to y2, and y of x3 is equal to y3. So you have to note that to use this Milne's predictor corrector method, the solution of the differential equation must be known at the four consecutive values of x, like this: x0, x1, x2, x3. x1 is nothing but x0 plus h, x2 is x1 plus h, x3 is x2 plus h. At every point, the value of y must be known. If these are known, we get a good solution for y at the next point at x is equal to x4. Usually in the exam, the solution they give at these 4 points, if they are not given, we can only sometimes they give the solution at this point only. So these three, at these 3 points, you have to get the solution using any method we have seen earlier. Or simple method is Euler's method you can use. Instead of modified formula, only Euler method. Using that, we can find the solution. So using Euler's method is y1 is given by, it's y naught plus h into f of x naught y naught, and y2 is y1 plus h into f of x1 y1. Using the same formula, get it, these values. They're given, it is okay. They're not given means using Euler formula, you can find it. Once the solution known at these 4 points, that Milne's predictor corrector method means one formula to predict and to correct. To predict the value of y at the point x is equal to x suffix 4, it is given by this. First, the value of y at x is equal to x4 is predicted using the formula. We write a p on the top of y. The meaning is that we are predicting the value of y at x is equal to x4. And the formula is y naught plus, that means the starting point y naught plus 4h by 3 into 2 times f1 minus f2 plus 2 times f3. Using this formula, you predict the solution. Then modify the answer. That means improve it using the corrector formula. So corrector formula means it is shown by writing y suffix to the power c. That means value of y at x is equal to x4, and it is corrected value of this. And it is given by y2 plus, you have to note the starting point here. Here it is y2, y naught, but here it is y2 plus h by 3 into, here is 4h by 3, but here h by 3, f2 plus 4 times f3 plus f4. So using this formula, you have to correct the solution. Where, what are these f1, f2, f3? These are nothing but f5. It's given by value of the function at x is equal to xi, y is equal to yi. That means f1 means value of f at x is equal to x1, comma, y is equal to y1. If you substitute, give the value of f5. Substitute. So this is used to predict the solution, to correct it. And again, sometimes if you are not satisfied with this answer, which means if this answer is not very near to predicted value, whatever the value got it, once again from that, find the value of f suffix 4 and substitute it. That you can modify. That means it is taken as an iterative formula. So, and this is the Milne's predictor corrector method. Let us see one example how to find the solution using this method. That means how many times the corrector formula you have to use, that's here given. So till we get the stationary values. Stationary solution means, suppose that here you got some value, it is very near to this means it is close to that. We say that is a stationary value. For difference is there means, then what to do means, from this y suffix 4, again find the value of f suffix 4 using this relation and substitute it. Only this value you have to change. All other values are one and the same. Once you change and get it, see whether it is very near to that. Very close answer, then stop it. That is the meaning of stationary solution is obtained. So this is what predictor corrector method. So the thing is, when a differential equation of this type is given, usually they give dy by dx is equal to f of x comma y. The value of y must be known at the 4 consecutive values of x. So they're not given, only one point is given, means using any method you have seen earlier, find these values, then substitute. Shall take one example here. So the question asked is, using Milne's predictor corrector method, obtain the solution of dy by dx is equal to x minus y square at the point x is equal to 0.8. And given that y of 0 is equal to 0, y of 0.2 is equal to 0.02, y of 0.4 is equal to 0.0795, and y of 0.6 is equal to 0.1762. So the solution for this differential equation, that means value of y, are given at consecutive values of x at 0, 0.2, 0.4, and 0.6. By knowing these 4 values, you have to find what is the value of y at x is equal to 0.2. So first write the given values. What is given? First f of x comma y, that means right hand side of the differential equation, x minus y square. And h, how to get h? See the difference between 2 consecutive values of x, 0 to 0.2 or 0.2 to 0.4 or 0.4 to 0.6. This difference is 0.2 only. So h is, we take it as 0.2 because at consecutive values of x, values must be given. So the difference between any 2 values of x is taken as h. So now what we need is first identify, first list it. What are these values of x and xi and yi? From the first condition, we see that x0 is 0, y0 is 0. Next, from the second condition, we see x1 is 0.2 and y1 is 0.02. And next condition, x2 is equal to 0.4 and y2 is equal to 0.0795. And from the last condition, it is x3 is equal to 0.6 and y3 is equal to 0.1762. Here the method is very simple. We need the value of f suffix y. So first we shall see what is f1, f2, f3. But f0 is not required here. So no need of finding the value of f0. Another method is there, that is Adams-Bashforth. For that we need f0 also, but that is not in the syllabus. So no need of finding the value of f0. Start from f1. So this is the predictor formula. So what is f1? F of x1 comma y1. That is f of x1 means 0.2, y1 is 0.02. So this value is not required. Note that f of 0.2 comma 0.02. But how f of x comma y is given? The relation between the variables is x minus y square. That means x coordinate minus square of the y coordinate. X coordinate is 0.2 minus square of the y coordinate. That means 0.02 square. On simplification, we see that it is 0.1996. Next, find f2. F2 means f of x2 comma y2. That is f of, this is x2, this one is y2. So f of 0.24 comma 0.0795. But f of x comma y is defined as, the relation is x minus y square. So x is 0.4 minus 0.0795 whole square. If you substitute it, you may see that there is 0.393679. Similarly, get the value of f3. F3 is f of x3 comma y3. That is, this is x3, it is y3. So f of 0.6 comma 0.1762. Now they are related by this relation 0.6 minus, that means x minus y square. X is 0.6, y is 0.1762 square. Simplify this on calculation. We see that it is 0.56895. So to predict the value of y at x is equal to x4, only the values of f1, f2, f3 must be known. Once it is obtained, substitute in the formula. So the predicted value of y is, it is denoted by y suffix 4 to the power p. The formula is y0 plus 4h by 3 into 2 times f1 minus f2 plus 2 times f3. Since all are here calculated, substitute in the formula. So we get y naught is 0 here. So it is h by 4h by 3. H means here 0.2 return, and this is 2 times f1 minus f2 plus 2 times f3. Everything is listed here. Simplify on calculation, we see that it is 0.30491. So all our algebra function easily can get this values using calculator. So it is 0.30491. Whether you have to accept or reject, that depending on the corrector formula. Now you have to correct it. In the corrector formula, f suffix 4 is required. So first you shall get f suffix 4. What is f suffix 4? That is f of x suffix 4 comma y suffix 4. But here written up to x3 only. Up to that value is given. So what is x4? If you add h to x3, it gives x4. So x4 is nothing but this 0.6 plus h 0.2. That is 0.8. So it is 0.8. Y suffix 4 means the value of y. Sorry, that the value of y at obtained by predicting the formula. That means using the predictor formula, you obtain this. This is called predicted value. So it is 0.30491. Now again, f of x comma y is defined as x minus y square. If you use it, so we see that this value is here 0.70702. Now substitute this values in the corrector formula. So this is the predicted formula. It is used to predict the solution. It is to correct the solution. So corrected value is y2 plus h by 3 into f2 plus 4 times f3 plus f4. So on simplification, just calculate this value, and we may see that this value is here 0.30460. You see that predicted value is 0.30491 and corrected value got 30460. So 3 digits are repeating. So we may judge that it is very good answer, because first 3 digits repeating means it is the answer corrected to 3 decimal places. If you want to improve the answer, once again this value substitute first from this value, get f suffix once again, taking x4 is equal to same value, y4 means this value substitute, it gives some value here near to that, and that value substitute here, all other values same. So we may see that the same answer is obtained. So if I again correct it, we get the same value. So we judge that or conclude that this is the value of y at x is equal to x4. So this is what predictor corrector method, Milne's predictor corrector method. So to get practice, I shall take one more example, similar to this, but here the condition you have to note. Using Milne's predictor corrector method, solve dy by dx is equal to x square plus y square at x is equal to 0.3 they ask to find a solution at 0.3, but values given are y of minus 0.01 is equal to some value, y of 0 is equal to 1, y of 0.1 is equal to this much, y of 0.2 is equal to this one. Here 5 solutions given, that means value of y at 5 consecutive values are given. Which one you have to take? Don't think the first 3 you have to take, first 4. So before 2.3, what are the 4 consecutive values in the descending order you have to take, right? So to get 0.3 here, h, the difference between 2 consecutive values of x is 0.1. So h is 0.1. So first value you have to get at 0.2, next 0.1, next 0. So these 3 values must be considered. So 0.2, 0.1, 0. From that, so sorry, here the 5 is not given. Sometimes in 5 values are given, 1 point you have to delete. But here the solution are known at the 4 values only. This is x0, it is x1, x2, x3. Sorry, 3 values at 4 values only given. So sometimes they give some more values. And some more values are given. You have to take first 4 values in the descending order. That you have to take. But here this is x0, not y of 0. This is x0, it is x1, x2, x3. That's all. Only 4 values are given. So similar to the previous problem. So f of x comma y is equal to x squared plus y squared, and h is 0.1. So first identify what is x0 is here minus 0.1, and y0 is this 0.90978. Like that, we can write all these values x0, sorry, x1, y1, similarly x2, y2, and x3, y3. x3 is here 0.2 and y3 is 1.2445. Once these points are identified, get these values right? The predictor formula, in the predictor formula, what are the values we need means f1, f2, f3 in addition to y0 and h. So f1 means the value of the function at x1, y1. X1 is here 0, y1 is 1. So f of 0, 1 you have to find. But f of xy, how we define? It's x square plus y square. Square and add the coordinates, x coordinate and y coordinate. So this value is 1 itself. Next find f2. f2 is f of x2, y2. That is x2 is 0.1, y2 is 1.1045. How they're related? That is x square plus y square. So this value is also obtained. It is 1.24309. Similarly, get f3. It is f of x3, y3. The values you may observe. It is x3 is 0.2 and y3 is 1.2445. The relation is x square plus y square. Square and add it. It gives 1.5886. We also calculate and check this answer. By knowing these three values, we can predict the value of y at x equal to x4. It is denoted by y suffix 4 to the power p. This is the prediction formula. All these values are known. Y0 is here 0.90978. But while taking y0, this value is to be considered, right? And this is 4h by 3, 2 times f1 minus f2 plus 2 times f3. The formula substituted and see what is this value. And it is observed that this value is equal to 1.4344. So like that, you have to calculate and get it. So once it is predicted, before correcting, we need the value of f suffix 4. So how to get f suffix 4? That is value of f at x is equal to x4, y is equal to y4. So what is x4? That also you have to know. x3 is 0.2. If you add h to x3, it gives x4. So x4 is nothing but 0.2 plus h. H is here 0.1. So 0.2 plus 0.1 is 0.3. So it is 0.3 and y suffix 4. That is this value, 1.4344. Now they're defined by x square plus y square. Square and add it. And you may see that this value is 2.1475. Now, when f suffix it is known, use the corrector formula. But the corrector formula, that is y2 plus h by 3 into f2 plus 2 times f3 plus f4. All these are calculated. So substitute in this formula the values of y2, h, f2, f3 and f4. And on simplification, we see that this value is equal to 1.4353. But here small difference is there. Here 4344, 4353. Only 2 digits are repeating. So it is the answer correct to 2 decimal places. So I have not taken the next iteration. If you want, you can improve by taking this one as y suffix 4. Once again, find f suffix 4. We get some values near to that. That value substitute again in this formula, same formula. So the next step, we get the same answer. Right? Sometimes there may be more difference in the last digit. The previous 3 digits will be the same. Same answer will be obtained. So this is what Milne's PC method. So one more problem is given. I'll definitely show this one. So it is the function given is dy by dx is equal to xy plus y square. The solution required at x equal to 0.4 and y of 0, y of 0.1, y of 0.2, y of 0.3 are given. First step you have to do is identifying all these values similar to the previous problem. So next you have to get, first write the formula also and get the value of f1. Next find the value of f2. So say only changing the relation. f2 also you can find. Next go for f3. So that you can find it, f3, f of x3, y3. So like that you can get all this. So since so all these 3 values are known means substitute the formula, predictor formula. If you substitute it, it gives the answer as, that will be 1.8344. Now this is the value of y at x is equal to x4 obtained by using the predictor formula, Milne's predictor formula. Now you have to correct it. Before correcting, you have to get the value of f suffix 4. How to get f suffix 4? That is f of x4 comma y4. What is x suffix 4? It is obtained by adding h to x3. x3 is equal to 0.3. Add h to this. H means here 0.1. If I add it, it gives 0.3 plus 0.1, it's 0.4. So it is 0.4 and y4 is 1.8344. That is f of x comma y. But how they related? The relation is here. It is written xy plus y square. So it is xy plus y square. See what is this? It is 4.88. Now correct it. Use the corrector formula. So corrector formula is y2 plus h by 3, the same f2 plus 4f3 plus 4f4.
Wow.
Substitution give the answer. It is also very near to the previous value 1.8386 you got. Predicted value is 1.8344. This is 1.8386. So somewhat close answers. So you can stop it, this iteration. So this is what Milne's predictor corrector method. So in this model, the first concept is that solving initial value problems using these 4-5 methods. So Taylor's series method I've seen. After that, Euler's modified method. Before that, Euler method. Then Runge-Kutta method of order 3, Runge-Kutta method of order 4, and last one, Milne's predictor corrector method I have seen. So this is the first one concept of this model. So another concept here is that is solution of integral equations. Solution of integral equation means here just hello. Please mute your mic. Otherwise some disturbance I have. Hello. Okay. Say now next concept is, so before that I'll give some more problems. You just try to solve these 3 differential equations using Milne's predictor corrector method. So just take down and try to get the answer for this. So 3 problems given here. Just write it and try to answer. But in the second question, the left hand side 2 times dy by dx there. So first, well, identify f of x comma y. Left hand side we should have only dy by dx. If anything else is there, you have to make free from that. So you have to divide this by 2. So when 2 is taken right hand side, it becomes 1 plus x squared into y squared divided by 2. That is taken as f of x comma y. So that you have to know. And rest of these things direct questions. Try to solve it. Now we shall go to this another concept in this model, that is numerical integration. Actually, they given title, that is solution of numerical equations, but here concept is only to solve some or to obtain the integration by numerical method. Actually, finding the value of an integral numerically means we take the geometrical meaning of integration. Actually, integration represents, so integrating a curve or integrating a function, geometrically equivalent to finding the area under the curve between 2 ordinates. Usually they ask, find the value of integral of f of x from a to b. The meaning is that finding the area under a curve between 2 ordinates x is equal to a and x is equal to b. So to integrate or to find the area, numerically what we do is we divide that area into small rectangles. By taking h is equal to small and small, we divide into equal rectangles. Then we find the area of each rectangle and add it. That gives the value of that integral. That means area under that curve. But finding the area of a rectangle is nothing but multiplying length and breadth. That we write in another form. So let us see how to do the integration of a function in the definite integral using this numerical method. For that, suppose that we need the value of this integral, that means integration of f of x with respect to x from a to b. Between 2 limits, you have to evaluate this integral. numerically, to get this answer, what we do is we divide this interval AB into n equal subintervals. This is the first step you do. Divide this interval AB into n equal subintervals. Say such that, or length of each interval, let it be h. How to divide means at the first point, say A, we shall take it as x naught. So take this x naught is equal to A, and x1 is equal to A plus h, that means x naught plus h. x2 is equal to x naught plus 2h. x naught plus 2h is equal to x1 plus h also you can write. And x3 is, that is either you can write x2 plus h or x naught plus 3h. Continue like this. The last one, that is xn is nothing but either you can write x naught plus nh or xn minus 1 plus h. That one you take it as b. So from A to B you have to reach, just giving increment, small equal increment to each, to the starting point A. So go on adding to this till you get B. So like that you have to divide. After dividing, this f of x is given. Find the value of y. Y means f of x at this xi values. That means let y naught, y1, y2, etc., yn be the values of y at x is equal to xi. That means at x naught, first to see what the value of y, let it be y naught. At x1, what the value of y, let it be y1. Like that, find these values. After that, depending on this number of division taken while dividing, we use some formula to get the value of this integral. So depending on there are some restrictions. Actually, how we get this formula means, first should know, we first get one quadrature formula by using Newton's forward interpolation. That theory part is not recorded here. So there is a formula for this. We replace this one by Newton's forward interpolation formula. Then we integrate this one with respect to x. But that formula will be in terms of n we get. N means the number of points taken there. Next, if you give some values to n, we get different formula. When n is equal to 1, we get a formula. It is called trapezoid rule. When n is equal to 2, we get another formula. It is called Simpson's 1/3 rule. When n is equal to 2, we get another formula. It's called Simpson's 3/8 rule. And for next value, we get Wedel's rule. So this four formulae first let us discuss. Only you have to remember this formula only. Here the question is how to evaluate this integral using this formula. So theory part we leave. Just you shall directly go to the formula. So first you shall see what this trapezoid rule. So when a problem of this type is given, first step you have to take is divide this interval AB into n equal parts. But if you divide this interval at one point, it means one division means how many ordinates we get. Ordinate means just like a piece. Suppose that take one line segment, cut it. One cut means if you bisect it, how many pieces we get? 2 pieces. So this 2 pieces equivalent to ordinates. Same line segment, if you trisect it, that means cut it at 2 places. 2 cuts means how many pieces we get? 3. One more than that we get. N cut means n plus 1 pieces we get. That pieces are called ordinates. So sometimes in the question they mention taking 6 ordinates. 6 ordinates means you should know that 5 cuts we need. That means n is equal to 5. So that you have to note. So depending on this, you use some formula. Let us see what are this formula. First one is, it is called trapezoid rule. In trapezoid rule, we integrate f of x from a to b using this formula. First, divide this one into n equal parts. Let it be x naught, x1, x2, etc., xn. X naught means a, xn means last value b. At each I, xi, find the value of y. Let it be y naught, y1, etc. Once these are known, that in trapezoid rule, the value of this integral is given by this h by t is common. Then, see the first value and last. Y naught is the value of y at a, yn is the value at b. That means value y means f of x, right? So first and last you add it, plus 2 times all remaining suffixes you add it. That means y1, y2, etc., yn minus 1. What are these yi? That's the value of y at x is equal to xi. So find all these values and add it. So this formula obtained, that is called trapezoidal rule. But for this, there is no restriction for this. Whatever the number of division, you can use it. If n is 10, 15, 10, whatever the division, you can use it. But some other formula, there is a condition at which division we have to use it. So this formula is called trapezoidal rule. Next one, let us see Simpson's one-third rule. In Simpson's one-third rule, that value of that integral is given by this formula. Here h by 2 into first and last plus 2 times all suffixes. That means all values of y outright. But in Simpson's one-third rule, this h by 3 is constant outside. Instead of h by 2 outright, h by 3, as its name tells, Simpson's one-third rule. So it is h by 3. The first term we have to write is sum of first and last terms. That is y0 plus yn plus then 2 times all even suffix values you have to write and 4 times all odd suffix values. That means first and last y0 plus yn, that first you have to write. After that 2 times y2 plus y4 plus etc. plus yn minus 2. All y even suffix values you write. Plus this is 2 times, 4 times all remaining means odd suffixes y1, y3, y5, y7, etc. y minus 1 and add it. This gives the value of this integral. So very simple formula. Using that you can get. So this is trapezoid rule. Next Simpson one-third rule. One more, 2 more formulas there. Better. Here to use it, there is a condition. That is, the given interval must be divided into even number of equal subintervals. Suppose that the question they mentioned, divided into 6 equal parts means you can use it. Divided into 5 equal parts means this formula cannot be used. Then you can use this formula only. Because trapezoid rule means there is no restriction for the number of division of the interval. But for Simpson's one-third rule, there is a condition. So sometimes they won't mention the formula to be used. They express in terms of the number of division. So given number, if it is divided into even number of subinterval means you can use Simpson's one-third rule. Next formula is Simpson's 3/8 rule. In 3/8 rule, the formula goes like this. Integral of f of x dx is given by, it is 3h by 8. As its name tells, 3 by 8. That is 3h by 2. And starting is similar to for all this. First value and last value, add it. Then 2 times all that y suffix 3 means multiple of 3 only outright. So first y3 plus y6 plus etc. yn minus 3. All multiple of 3 as suffix. That is only taken. For that multiply 2 plus 3 times all remaining suffixes. What is left, write it and multiply 3. Add it and multiply 3. So this formula is called Simpson's 3/8 rule. But to use this method, there is a condition that the number of subinterval must be multiple of 3. Suppose the question is divided into 3 equal subcompartments, you can use. Or 6 means you can use, 9 means you can use, or 12 division is possible, 15 division possible, but it must be multiple of 3. Then only you can use this. Usually sometimes they give some points. So you should know how many divisions done. With respect to that, you have to use the formula. So if it is multiple of 3 means no problem. Next, last formula is Weddell's rule. Weddell's rule means here there's a condition is the number of division is 6, multiple of 6. Minimum division need here is 6. Either 6 division or 12 or 18 or 24. Any multiple of 6, we can use it. And formula is just not like the previous 3. Somewhat difference is there. How to write the formula means Weddell's rule, there's a constant common factor 3h by 10. Then instead of writing first and last, you shall write in this order. That is, suppose the only 6 divisions there. Only 6 division means you write up to this much only. That is y0 to y6. Only 6 division. So what the formula means? y0 plus 5 times y1 plus y2. 6 times y3 plus y4. 5 times y5 plus y suffix 6. We may see there is symmetry here. y3 its suffix is 3. Before that, alternately that functions are multiplied or not multiplied. See, y0 is not multiplied by any number, but y1 is multiplied by 5. The same thing comes here also. 5 times y5. It is y0 first and last here written. y0, y6, no multiplication. y1 and y5 multiply by 5, and again here y2 and y4 no multiplication, and middle one is 6y3. So only 6 division means you add up to this much. Suppose the question is using Weather's rule taking 12 division. 12 division means again to this y suffix 6 add this much terms. That is again start from y suffix 6. Here it comes twice. Then 5 times y7 plus y8, 6 times yn plus y10 plus 5 times y11 plus y12. How you return the same pattern, it also move. That is for 12 division. If it is 80 division, continue like this. So this is called Weather's rule. So here the minimum number of division is 6, but for Simpson's 1/3 rule, it is even number of divisions. For 3/3 rule, it's multiple of 3. So this condition must be known. But for trapezoid rule, no restrictions there. So the formula return. Now the question usually in the exam they ask, you are late, the integral. If the method is not mentioned, you can use any method here, right? So only 1 minute is remaining. So that problems let us discuss in the next class. So which problems given, any formula cannot be used, sir. You should not, depending on the number of division. If it is mentioned 10 division, means in the last exam, they given a problem, question was mistake there, because for 10 division, which method you can use? For 10 division means you can use trapezoid rule and Simpson's 1/3 rule, but not 3/10 Weather's rule. It's not possible. But in the last exam, what they asked is, that was mistake. They asked to solve that problem using 1/3 rule, 3/3 rule, and Weather's rule. They mentioned, but these two rules cannot be applied for that if 10 division is there. 10 division means it is multiple of 2 only, either even number or no restriction. These two formula only can use it, right? Let you note, right? So otherwise, that method is very simple. Depending on the number of division, you have to use it. But if it is not mentioned, means all the formula you can use, which whether it is